Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll continue a review of some research methods concepts that will be important for the statistics course. We will begin by discussing the different types of variables one can have in a research study. What is a variable exactly? Well, a variable is the concept we are trying to measure. That is, variables are the measures of interest in our research study. In the social sciences, it is often a behavior. But variables could be a lot of things. Personality traits like extroversion, for example, academic performance scores, economic measures like poverty and inflation, or biological measures like height and weight. Independent variables are usually the variables that we control in our study. In experimental designs, we manipulate the independent variable so that we can see its effect on another variable. In these situations, the independent variable often has two categories, a treatment group and a control group. We hypothesize that the independent variable has some effect on the dependent variable, which is why it is included in the experiment. Often we refer to independent variables as predictors because they predict the dependent variables. For example, if you are testing out the effectiveness of a sleep medicine, you might assign a group of people to have the sleeping pill and a group to have a placebo pill. Pill assignment, sleeping pill or placebo, would be your independent variable. The dependent variable is not manipulated in a research study, it is simply observed. Dependent variables are also often called outcomes, that is, they are the outcomes of interest in a study. Using the same example, the dependent variable would be some biological or self-reported measure of sleep quantity, either using a Fitbit app to measure people's sleep hours or having them report to you how much they slept. Throughout the course, you may hear me refer to some other types of variables as well. Another common type of independent variable is a covariate, also known as a control. Covariates are other predictors we include in our studies that are usually participant characteristics such as age, gender, ethnicity, or socioeconomic status. We'll talk more about why we include covariates in our analyses later in the course. A confounder is also an independent variable and is a variable we include in studies because it has a relation with the predictor of interest. A confounder might be responsible for the observed relation between your predictor and your outcome of interest. A classic confounding example is the relation between ice cream sales and shark attacks. Every year, increasing ice cream sales are related to increased shark attacks. The confounding variable is temperature, because hotter weather means both more people at the beach and therefore more shark attacks, and higher ice cream sales. People like more ice cream when it's hotter out. Each type of variable you study has a measurement scale. Nominal variables are variables that have no numeric scale. That is, they are just coded categories that are not ranked in any way. Examples of nominal variables are eye color or college attended. For example, green eyes aren't ranked higher on any scale than blue or brown eyes. They are just a different color, so each color would have a code. Ordinal variables have values that are ranked in some way, but there is no meaningful numeric difference between those values. We see ordinal variables a lot in research. One common example are customer satisfaction questions. We often see these questions with a scale that ranges from very happy to unhappy. This scale is ordinal because the difference between one customer's happiness and unhappiness might be quite different from another's, so there is no meaningful difference between the levels of the scale. Interval variables are rank ordered and they do have meaningful differences between values, but they have no true 0 point. For example, IQ scales have no true 0 point because with an IQ of 0, you'd be dead and we wouldn't be able to take a measure from you. When IQ is measured, it is always greater than 0. Temperature also has no meaningful 0 point. There is a temperature of 0, but it does not mean no heat or lack of temperature. Finally, ratio variables are rank ordered with meaningful differences between values, and they do have a true 0 point. For example, Time is a ratio variable. When time is at 0, that is the beginning point of whatever is being measured. There are 3 important properties to help us define and remember the scales of measurement. These properties are order, difference, and ratio. Order refers to rank ordering, meaning a larger number represents a greater value than a smaller number. Difference means that the difference between 2 numbers represents some meaningful value. Ratio means that the division of one number by another has some meaningful value. For example, I've already said that IQ is an interval variable. So we wouldn't say that IQ equals 100 is twice as intelligent as IQ equals 50, because we can't, and that IQ equals 50 is halfway in intelligence between 100 and 0. We just say it's a certain number of points above or below, but we can't make any multiplicative statements. For example, twice as intelligent or 3 times as intelligent. With weight, which is ratio, having a true 0 point does allow you to say that 10 is twice as heavy as 5. Here is a handy table to help you remember the properties of each scale. Okay, now that we've covered types and scales of variables, let's talk about samples. A sample of data is a subset from a bigger population. Here, the data come from one big pool, represented by the blue circle. This blue pool is the population of data points. The sample of data points are only the data points in the pink circle. So for example, let's say I take a survey from 5 students in the class. The 5 students would be my sample out of the larger population of students in the class. Population estimates are referred to using Greek letters, and sample estimates are referred to using Roman letters. We'll talk about this a little bit more in later lectures. Sampling has to do with the process by which people are selected for the study. In a random sample, every person in the population is equally likely to be selected for the sample. In a convenience sample, certain people in the population have a disproportionate chance of being selected for the study. This can lead to bias, which means that the effects we observe from the study could be the result of the sampling method instead of an actual treatment effect. This could lead us to inaccurate conclusions. For example, if I go to a nursing home and ask people what they are watching on TV, I won't have a representative sample of the US population's TV watching habits. We'd conclude that the whole US is watching Golden Girls and Murder, She Wrote. We try to randomly sample for participants whenever possible, because a random sample should lead to accurate conclusions. An example of a random sampling procedure would be surveying people using random digit dialing, which randomly creates phone numbers for you to call. Related to sampling is the concept of random assignment. Random assignment refers to choosing conditions for participants within a sample after the sample has already been drawn. So random assignment can be done with either random or convenience samples. Suppose I wanted to do an experiment with my class and I decided to try 3 different grading techniques. I could generate an algorithm on my computer that randomly assigns a number of 1, 2, or 3 to a student. Students in group 1 are graded with the first technique, students in group 2 are graded with the second, and so on. This would give me 3 randomly assigned groups that I could use to try out my 3 different grading techniques. But suppose I allow students to select the technique they would like me to use. Students with high GPAs might think one grading technique is easier, and students with low GPAs might think another grading technique is easier, so they would select into different groups. Then I wouldn't really know if one technique is better than another because my results could be due to overall student performance. Random assignment plays a big role in defining different types of research designs. The type of research study you conduct depends on the variables you are interested in. Some variables can be manipulated, like assignment to types of therapy, while others cannot, like gender, ethnicity, or genetic predispositions. Observational studies make no attempt to manipulate variables, and they have no treatment or control group. In these studies, the researcher is only interested in assessing relationships between naturally occurring variables. For example, a psychologist might be interested in assessing the relationship between intelligence and job success. Neither variable is manipulated, they're only observed. Quasi-experiments are characterized by naturally occurring treatment and control groups. In quasi-experiments, the researcher has little or no control over who is assigned to the treatment and control group, and participants may self-select into groups. A study with a treatment group only and no control group is also considered a quasi-experiment. An example of a quasi-experiment would be a study of a treatment for depression where participants are allowed to choose either a drug therapy or a behavior therapy. In this example, there is no random assignment and there is no control group, only 2 treatment groups. Finally, experiments are defined by the presence of random assignment to conditions. The researcher manipulates the independent variable so that each participant has an equal probability of being in any of the conditions of the experiment. An example of an experiment would be a study of the effectiveness of aspirin, where participants are randomly assigned to be given either an aspirin or a placebo sugar pill. Experiments are the gold standard for scientific research, where we attempt to control as many characteristics of our studies as possible. This concludes the second lecture on research design. In the next lecture, I'll review basic descriptive and inferential statistics and introduce the concept of modeling data.